This question is from the Bay Area JavaScript interview meetup on 2nd of August. Given an unsorted array of integers, some of them are duplicates but some are not, what is the best time complexity to sort the array in ascending order? Pause the video and see if you can solve it. First of all, any language has their own inbuilt sorting libraries. So quicksort, normal time complexity is n log n, worst is n squared, merge sort and keep sort is n log n. The fact that this is an interview question, what that means is that you have to do better than n log n. And when you say n log n to the interviewer, please state explicitly what n is. So n is the size of the array. So our objective is to beat n log n, where n is the size of the array. In this case, it will be 15. In this video, I'm going to introduce 4 methods. Each of them will beat n log n. And in order to properly introduce these 4 methods, these 4 algorithms, I'm going to introduce 2 more variables. The first is k, where k represents the number of unique elements. Now in this case, we can tell 6 is a unique element, 4, 3, 2, -3, 0. That is pretty much it. So our number of unique elements should be 6, right? In this case, it is 6. Let me ask you this question. What do you think is the relationship between k and n? Your k should be less than equal to n, right? Because k is the number of unique elements. So one way of thinking about beating n log n is if you can somehow introduce a k there, like n log k or k log k, that is considered better than n log n. I'm going to introduce another variable called m, where m stands for the maximum element of the array. In this case, it will be 6 also, but it just happens that the maximum is 6. Now let me ask you, what do you think is the relationship between m and n? Now m has nothing to do with n. Reason being, you can have an array that is 1,000, 0. So your n is 2, right? But your m is 1,000. So in this case, your m is greater than n. You can also have an array that's 1, 1, 1, 1, 1. You can have 101 here. So your n is 100, but your m is 1. So your m is greater than n. So m has nothing to do with n. Now today I'm going to introduce 4 algorithms. Their time complexity are n log k, k log k, all of max m n, and a potential all of n. Now these 2 are normal time complexity. The worst time complexity is still n log n because k can be the same as n. But this really should be k log k. It's a typo. Okay, so what is the intuition here? In order to achieve these algorithms, we need to sort less things. In order to sort less things, we can compress our original array into a representation of array of counts of each unique element. For example, for 6, how many counts are there? Looks like there are 3, 1, 2, and 3. For 4, how many are there? So now you've created a representation. Our total number of unique elements, it is now k, which is 6. So when you sort this representation, you're only sorting 6 elements, or k elements. So the time is k log k. So where does this n log k come from? It really depends on how you implemented this count map. If you use a pure hash map that does not have ordered index, this will be a representation. Then you will sort this, probably store it in another array. You have k log k. However, if you use a ordered map, for example, a map in C++ or a sorted map in Java, as you are pushing the elements, your map will automatically have a sorted index. So it will become like this automatically. then you do not have to sort it later on your own. However, as you are pushing, you will do a log of k operation for each push, and you are doing it for n times. Don't worry, I'll explain it later when we are doing the coding. Let us first do the unlock k algorithm. So we're going to use C++. This is our input array, which is called v. We're going to invoke a function called f, which is here. And f is going to take in the input of v and spit out a result array of res, and we are going to print it, right? So f take in v and spit out res. So let's do res, which is an array. Now we are going to use a ordered map. So as we are pushing pairs of key value pairs onto the map will automatically sort the index. For int I in v, count v on I plus plus. For auto I count. For int j0, j less than I. Now count is the second, so second plus j. Oh boy. Now res dot in place back means just means array push. It will push the first. Cool. Let us see what we got. -3, -3, 0 to 2, 3, 3. Looks like it works. Now, why is this unlock k? First of all, this is a linear operation, so there's an n here. Now, this is a log k operation. Reason being, this is an insertion onto an ordered map. Let's refer to Geek for Geeks. This is an insertion, and your time complexity of an insertion onto an ordered map is log of n. He's using n here, where n is the size of the map. We are using the notation of k. Now, why when you push onto an ordered map the time complexity log of n? Because map is actually a red-black tree. You know what is a red-black tree? It is a self-balancing binary search tree. So your height of the tree will always be log of n. That is why your maximum time complexity of each push will be the total height, which is log of n. Yeah, when I say log of n, I actually mean log of k. So when you do log of k for n times, you will be n log k. So what we did just now in C++ is this representation. Now let us do k log k. In k log k, we're going to use JavaScript because why not? Let's copy paste. Let's call it k log k JS. K log k. Your array will be this because I just copy pasted. We're going to use an object to represent a hash table. Call it obj. I guess my array can be const. Yeah, let's make it const. So you look through the array for each element. Now if something is in object, how do you test a property is in an object? Go Stack Overflow. How do you test it? You can use this notation. I mean, if 1,000 people upvote a post, it must be true, right? If it is inside, plus obj e, else it is 1. If you want to be fancy, you can also do in one line, which is obj e equals to if e in obj e plus 1, else 1, right? can remove this. What is wrong? Okay, so console log to test it out. obj node klog k 0 1 2. Looks like it works, right? Now because we are using a object, so we are not sorting any index. So that's why our index is not sorted. The length of our object is k, right? Now, so let us sort it. In order to sort it, we're gonna sort in an array. Let us call it result. I'm just gonna call it sorted. Don't ever sort anything in an object, right? Sort it in an array. So let us loop through. When you loop through a object, you use let in the object. So you push a val and a count. So you will do, is this correct? I don't know. Let's test it out. Sorted. Let's run it again. Oh, I need to do this. I forgot it's an array. So let us sort this. Sorted. No. Sorted dot sort. A B. You sort the first, so you sort by index 0. Then you log again. Start, oh, B0. So it looks like it works. Now all we need to do is to declare a res array. So you just sort it dot for each, right? Each element. Now your res.push. Now you have a let I is count. What is our count? Count is E1, right? Plus I res.push. Who do I push? I need to push U, right? So console log res. Let's see if it works. Oh, what is going on here? No, push E0. 0. Looks like it works. -3, 0, 2, 2, 2. Okay, so it works. So what did we do just now? We just use JavaScript object as a hash table to store every count. Now our index is not sorted, so our pushing operation into the object is a all of n operation. Then we have an object with the length of k, so we transfer the data into an array of arrays, which we call sorted, and we sort that because the length is k, so it's k log k. Well, you can also say it's all of n, but k log k is upper bound. Now we have finished these two, so let us move on to all of max mn. Now this algorithm is also called trivial hashing or index mapping. I'll leave a link to the source here. You can later look it up. In trivial hashing or index mapping, what we're going to do is to have an array. Let us use an array without negative numbers. I'll talk about negative numbers later. In order for this to be a linear, be all of max m n operation, where n is the size of the array, so in this case it will be 5, 9, that total of 9 here, so n is 9, and m is 6, right? Because the maximum element is 6. What trivial hashing does is to reserve 7 spaces. 7 is your m plus 1, because you have 0, 1, 2, 3, 4, 5, 6. That is reserve 7 spaces. I'm going to mark the index. What we're going to do is to map. This is your original array, right? Original. This is our representation. What you're gonna do is to map your original array's value to my representation array's index, and map the original array's count to my representation array's values. Let me explain. So when you look through the original array, you encounter a 3, so I will go to index 3 and increment count by 1. 0, I come to here, increment by 1. 1, increment by 1. 6, increment by 6. 3, add 1. 3, add 1. 6, add 1. 2, add 1. 2, add 1. Let me clean it up. So I have created a representation of your original array, where this 3 represents your original array has 3 times. Okay, so this 2 means your original array has 6 2 times. Then we push this representation into a result array. So we just loop through from the beginning. There's 0 1 time, there's 1 1 time, 2 2 times, 3 3 times, no 4, no 5, and 6 2 times. Now, what is the time complexity of this algorithm? It is the maximum of m and n, because you do not know whether m is bigger or n is bigger. Now, what is the downside of this algorithm? Obviously, if you have an array that is 0, 10, and 1,000, your n is 3, right? But your m is 1,000. Well, 1,001, well, it doesn't really matter. So you have a lot of space. Your space, you have 1,001 space. So it's kind of ridiculous. It's a little bit overkill. So this is the downside. What is the upside? Your upside is you only have 3 numbers. Let's say 0, 1, 1. So you have 101 here. Then you have a bunch of 0, 100, 0 here. Then you have 2, 102 here. Your n is something ridiculous like 300, but your m is only 2. So my representation will only have 3 number, right? 0, 1, 2. Then I just increment the count. Now you see the power of this algorithm. It's kind of unstable. It really depends on your input. So I guess during an interview, you cannot say this is better or worse. You need to say at worst circumstance it performed better, and at worst circumstance it performed worse. So in this case, it's better, but in this case it's worse, right? Let us code it out in JavaScript. I'm gonna call it maxmn. Maxmn. I'm gonna copy paste the same array from just now. Go to maxmn, call it array. Notice we have negative number here, so we cannot simply do a naive map into our representation. We need to do some sort of data transformation. In order to do that data transformation, we need 2 numbers, a max and a minimum. I'm going to initialize my map as -infinity, minimum as infinity. I loop through and override at every visit. So max will be max between e and max. Mean will be max. No, mean between e and mean. Let us see what our max and mean is. Node max mnjs. No, max is 6, negative, mean is -3. Okay, so let us create our representation array. So how many space are we gonna reserve? We're gonna reserve max minus mean. Oh, you know what? Let me just max minus equals to mean. So our max should be 9 now, right? So you reserve 10 spaces because you also have 0. Fill it up with 0. which is the original count. So let me just put a comment. Max is 9. Your min is -3, right? So now what you need to do is to increment the count inside your representation array. Now you need to do some sort of data transformation. So instead of just doing this, you have to do a minus e min. Let's see what we got. 2001. The reason I do this minus min is because our -3 originally will map to 0, right? We do not have -3 index, so we need to push everything to the right by 3 spaces. This 3 is the absolute value of your negative number. I hope this is not confusing you, but if it is, just run through your own. We are running out of time. This just means -3 2 times, no -2, no -1, you have 0 1 time, so on and so forth. And this 3 just means you have 6 3 times. Last but not least, we can make it const. Yeah, this can also be const. Let us do result array. So you push everything onto the result array. So rep dot for each element. For let I is 0, I less than, count should be e plus I rep res dot push. Well, we also need your index idx. So when we push, so if this is 0, so we need to push I index plus minimum. Console log res, see what we got. -3, 0. Looks like it works. Let's compare. Yep, it does work. So we have just implemented this O max mn solution. Now there is actually another solution which is a potential O of n. So you do not have wacky cases such that you have 0, 10, like a million. So m is extremely big, but n is small. However, this solution is considered a hack. So I will not be running through in this video. If you're interested, I'll make another video about it. So do check it out I'll put the link in the description. Otherwise, I'll see you next time.